Hi everyone, you all must have seen birds sitting on those high tension power lines without getting electrocuted, meaning they don't get any electric shock. Now, how is that possible? Because those cables are at very high voltage. Well, the answer of this question is very simple. If you have done your school physics, you must have learned that because the two legs of the bird are on the same power line, if the voltage of the power line is, let's say, 10,000 volt, very high, but since both the legs are at the same power line, this leg is also at 10,000 volt, this leg is also at 10,000 volt. So the voltage difference becomes 0. And if there is no voltage difference, current does not flow through the body of the bird. And hence it doesn't get any electric shock. It's very similar to if there is no temperature difference, we say there is no heat flow, right? So for heat flow, we need temperature difference. Similarly, for current to flow, we need voltage difference. But in the case of the bird which is sitting on the same power line, there is no voltage difference, so no current. Now, if the answer of this question is so simple, why are we discussing it here? Well, I want all of you to look at this question which came in KVPY examination in the year 2017. The question says, a bird sitting on a single high tension wire does not get electrocuted because option A, the circuit is not complete, option B, the bird feet has an insulating covering, option C, the capacitance of the bird is too small and the line frequency is too small, option D, resistance of the bird is too high. Now, none of the options matches with the answer which we gave before, right? Before, the answer which we gave was both the legs are at same voltage, so current will not flow. But here that option is not there. So most of the students went with option A. Now why most of the students went with option A is because we said both the legs are at same potential, right? So it's like saying both the legs are connected to the same terminal of a battery. And if that happens, the circuit is in a way not complete, right? And therefore no current flows. And therefore most of the students went with option A. Had it been this way, then the circuit would have been complete, right? If the circuit was like this, it would be complete and current would flow and the bird would get electric shock. But since both the legs are at the same potential, it is something like this in circuit diagram, and therefore they felt the circuit is not complete and they went with option A. But the answer key given by KVPY was, the correct answer was option C. Now, if you look at option C, you will find there is a mention of capacitance and line frequency. Now, capacitance is not taught in class 10 physics syllabus. However, we do study capacitance in class 12. And we must also understand the line voltage of the power lines are not DC voltage like batteries, but they are actually alternating voltage. And in the chapter called alternating current, we learned that capacitance can oppose alternating current, and the opposition of capacitance to alternating current is what we call capacitive reactance. And the formula for that, if you know, is given by Xc is equals to 1 by C omega, and omega is what we call the angular frequency, which is related to the frequency of the voltage. Now, since the bird is quite small in size, capacitance of the bird will be also very small, right? So capacitance of bird is very small, because if you remember, for a spherical conductor whose radius is r, the capacitance of that spherical conductor is 4 pi epsilon naught r. And if the size is very small, radius will be small, so capacitance will be very small. Also, the frequency of those voltage lines in our country, India, is 50 Hz only. So, frequency is also quite small, 50 Hz. So, since both these two parameters are very small, the reactance, which is nothing but the opposition to alternating current by the bird, this reactance is very high. And thus the current through the bird, whatever AC current flows through the bird, will be very less, because the current which we measure by something called RMS current would be the voltage of the power lines applied to the bird with respect to the ground, and that voltage divided by reactance would be the alternating current, which is measured as RMS current. And since this reactance is very high, the current through the bird, the alternating current through the bird would be very small. And that's the reason why the bird doesn't get electrocuted by alternating current. So that would be the right option in this case. I was thinking, why don't we estimate how much RMS current would actually flow through the bird due to the alternating voltage of the power line. So here is a simple circuit which I have taken. I have neglected the resistances. So here is the AC source. This would be representing the voltage between the power line and the ground. Okay. And this is the capacitance between the bird and the ground. Now actually the formula for that is something like this, which you study in class 12 syllabus, where a round conductor is inside another round big conductor. However, in this case, Earth is very big, right? So this would be the radius of the Earth and this would be the radius of the bird. I am assuming the bird to be a small spherical conductor. So if the radius of Earth is very big compared to radius of the bird, then this can be neglected in the subtraction, right? And then this R gets cancelled, and that is how I can write the capacitance of the bird as 4 pi epsilon naught R. Okay, capital R gets cancelled. So this would be the capacitance of the bird. If I substitute the values, I get, I have assumed the radius of the bird to be around 10 centimeter, which would be 0.1 meter, right? So I would get a very small capacitance, you can see around 1 picofarad, which is 10 power minus 12 farad. And if I assume a high voltage also, RMS voltage of 10,000 volt, then the current that flows through the capacitor is Vrms by Xc, and Vrms Xc is 1 by C omega, omega is 2 pi f, right? So if you substitute the values, the current that we get is 3.14 into 10 power minus 5 ampere, which can be written 0.0314 milliampere, right? Because 10 power minus 5 can be written 10 power minus 2 into 10 power minus 3, and 10 power minus 3 ampere is 1 milliampere. Now this current is very small. In order to get even a tingling sensation, we need a current of at least 1 milliampere, and this is much smaller than that. And to get an appreciable electric shock, you need around 15 to 20 or 30 milliampere. So this is very small, and that's why the bird is quite safe.